Hi everyone, this is Brianna, and this video is going to show you how to work on the 608 project, number 2. Just to take note, I've changed some of my variables around a little bit, just tweaked the values so that are not exactly the same as the ones that you're going to have. So, if you're doing this side by side with me and you see my values are different in the output, that's because I purposely changed them. So you can't just take the values from this, you'll have to do it yourself. But other than that, I will show you pretty closely step by step how to do everything. So first off, for 1A, Bill asks for the measures of central tendency. So we know those are mean, median, and mode. You guys have already gotten the mean before, but median mode are probably new for you. So the easiest way to do that in SPSS is, rather than going to descriptives the way we did last time, this time we'll do analyze, descriptive statistics. Sorry about that. So analyze, descriptive statistics, and then frequencies. And I'll show you why frequencies is much easier than descriptives for purposes of this project. So let's go ahead. You're going to need to choose a few variables that are listed in the project, but I'll just choose a couple for now. Put in whichever variables you want the descriptives for, and then you'll go to statistics. And right here you'll see central tendencies. You just click off all three of those. And then while you're here, you'll notice that some of the statistics that you're going to need to answer 1B, like range, variance, standard deviation, skewness, and kurtosis, all of those are right down here. So go ahead and check those off and request them now. It'll save you some time. And for skewness and kurtosis, checking these off will automatically get you the standard error values for each of these statistics. So this will actually give you everything you need for 1B. So then we can click continue. Once you have all of your variables in, you'll just say okay, and you don't necessarily need the frequency tables, but we'll just leave them for now. Okay. So you see here, here's my statistics table, and it gives me the mean, median, mode, all of our values that we asked for, the skewness, the standard error of the skewness, all of these for each variable that we requested it for. And for MyStat users, just to make a quick note, it's kind of hard to find the mode in MyStat. If you can't find it, what you could do is just request a frequency table for each of the variables. And then what you would do is, since we know the mode is the value that occurs most frequently in the sample, you would just go and see which of the values occurred most frequently. So, in this frequency table for whose, you would just look and you would find, it should be, I'm not going to do it right now, but you would find the highest number in this column right here, the first column. I think, let me just scroll back up, sorry. Yep, so you just look for the highest frequency, and that would be your mode for whichever value has the highest frequency. Okay, sorry SPSS users, we'll get right back to you. So that takes care of 1A and B, and then C, I didn't write down all the questions, but I think C might just ask you to, okay, so compute skewness, kurtosis, and your standard errors. We did that already. All right, onward and upward. So now we are on to 1D, which asks if there's evidence of skewness. So of course you guys are going to have to answer this, but just to remind you, the way that you would do that is you would take your skewness value and divide it by the standard error of skewness. And generally speaking, there's a cutoff of 2, that if it's greater than 2, or the absolute value is greater than 2, it would be significant. So you'll have to make a judgment call there and explain your thought process, and tell me whether there's evidence of skewness. And then for the last part of number 1 is to find the histogram for FEM. So let's do that. So to get the histogram, you'll go to Analyze, Descriptive Statistics, Explore. You're going to look for FEM, so why don't we just throw that in there. Put that in the dependent list. The factor list would be like, let's say I wanted to look at two different histograms, one for females and one for males on their femininity scores. So I would put gender as the factor list, and then it would give me a separate histogram for males and females. We're not doing that. We just want one histogram for the entire sample for femme. So that's fine if you leave it like that. And then you just simply go to Platts and you would check off histogram. And then while you're here, you might as well check off stem and leaf plat, because you're going to need that for number 4. So you would go ahead and do that and just click OK. Takes a second to load. Okay, so here's our histogram for femme. And I don't know, but it looks pretty skewed to me. So it looks like it's negatively skewed, so let's keep that in mind in a bit. Okay, so let's move on to number 2 now. It asks you to transform femme to reduce skewness. Use square root and log transform. So again, just a recap. Again, I changed my numbers, but yours are probably going to be pretty similar to mine. If you were to find that femme was positively skewed, you would be able to go right ahead and do your square root and log transforms without a problem, and that would help reduce the skew. But if you find that it's negatively skewed, then that's an issue, because you're going to have to invert the variable or make it positively skewed before you move on. So what inverting it would be, or in order to flip it to make it positively skewed, you can do that in a couple ways, but the goal, let me just pull up the histogram, the goal would be to flip this distribution so that it's positively skewed and instead of negatively skewed, which would just be like a mirror image of this. Like most of our values would be over here instead of over here, and then there would be a few outliers toward the positive end over here. You'll understand a little bit more what I'm doing when I show you how to physically do it. So let's go ahead and do that. But one of the easiest ways to do it, there are a couple of different ways, but one of the easiest ways to do it is just to compute a new variable that is gonna simply by, like, even if you just multiply times -1, you just want something that's going to take your highest values and make them the smallest, and the vice versa. You take your smallest values and make them super high. So let's go ahead and do that, and we'll check the histogram so that I can show you what I mean. But we'll go to transform, compute variable, then I'll show you how I did that. So we're going to call ours inverse femme, or inverted femme 10. That's what the INV is going to stand for, inverted femme 10. And I'll show you why I'm calling it that exactly. So one thing is, if we do it like this, if we multiply our femme variable by -1, it'll accomplish that job of flipping the distribution so that it's positively skewed instead of negatively skewed. But the only thing is that because we're going to make all of our values negative, that's going to be a problem for when we want to do square root transform in the next step. So we're going to just, after we multiply everything by -1, we're actually going to add 10 to that. So let's go ahead and first do femme times -1. So femme times -1, and for orders of operations, we need to put this in parentheses, and then you can just do plus 10. And then you can say, okay, let's make sure it came up. Okay, so this is our new column right here, inverted femme plus 10. And if you wanted to play around with it, you could do that. -3 or 3.55 times -1 would be -3.55 plus 10 should be 6.45. And then the next thing that we're going to want to do is our square root transform. But actually, before I do that, really quickly, I just want to show you what it looks like at this point if we were to look at the histogram. So again, Analyze descriptives, explore. And we'll switch up fem for inverse fem 10 or inverted fem 10. I keep saying inverse, it's not, it's inverted fem 10. And we just want the histogram. And hopefully what we're looking for is that mirror image that I showed you. So a positively skewed histogram rather than a negatively skewed one like it was before. Let's see. Aha, we got it. Okay, so this is what I was looking for. So now when we take the square root transform, it'll accomplish our goal of reducing skew because, you know, when we take the square root of values, it makes them smaller. So something like this outlier right here will be brought in toward the rest of the distribution. So that's the goal of what we're doing. At this point, though, you can see our inverse fem10 still has the same exact skewness as it did before. This is just a preparation step for actually doing the square root transform. Let me just check on the time really quickly. All right, we have a few more minutes. The video can only be 15, so I just had to check. Okay, so let's go ahead and create our square root transform. The way we're going to do that, pretty self-explanatory. You might already have figured this out, but compute variable, and then square root fem is what I'm going to call mine. You can call yours whatever you want, as long as you know that it's the square root transform. The way we're going to do this is arithmetic under function group, and then square root option down here. If you double click, it'll go up to our numeric expression box, and we are going to put in, don't put in fem, remember, do your inverse fem 10 value, and click OK. Let's take a look. Okay, so we have our new transformed square root fem value right here. So what you want to do right here and now is check the skewness value for this variable comparatively to what you got for the skewness of fem. It should have gone down. If it didn't, there's a chance that you did something wrong. So take a look at that now. I'm not going to do that for purposes of time. I just want to save a little bit of time. I'm going to go ahead and create the log transform, which is the next step. So again, for the log transform, the biggest thing is you can't have any zero values. So we're going to go back to our inverse fem 10. So when we make our log transform value, we're not going to use the square root fem. We're going to go back and you base it off of this variable. So we don't have any zero ones here. You probably won't in yours either. Just double check. You can do that by looking at the minimum and maximum, but we're all set here, so there shouldn't be any zero values. So we can go ahead and create our log transform by going to transform compute variable. I'll call it log fem. And then what you would want to do is function group arithmetic, ln, which stands for natural log. Whoops. Delete all this. We don't want all of this in here. So it'll just pop, when you double click it pops up ln. Sorry, I'm making this way more confusing than it has to be. So just look like this. And then you need to put, again, your inverse fem 10 into your natural log function. Let's see. Okay, it looks like it computed okay. And again, you want to pull up the skewness statistics. It should have gone down. So let me just check on the time. I'm going to stop it here and I'll start up a new video probably. Nope, I have 1 minute left. I'm going to keep going. So just to finish off number 2, it asks you to report the descriptives for fem, square root fem, and log fem. So you just want to go and do that. You guys already know how to do this, the descriptives. The biggest thing would be to get skewness and kurtosis. So you can do that through frequencies or through analyze descriptive statistics. And again, the biggest thing is that you're going to get the skewness and kurtosis, and you want to make sure that those decreased in both of your transformed fem variables. So you'll put that output onto your homework, And then you have to answer which one you would report descriptively, like if you were reporting in an article what your mean and standard deviation of femininity was. So you have to say which of those three values you would report for that.